Welcome to today's ArXiv CS Digest for April 3rd, 2026. We received 544 new computer science papers today across 57 subfields. Let's dive into the top picks. Trend 1 of 5, LLM behavior, confidence, and data. This trend investigates LLM behavior, confidence, and the data that shapes their capabilities, reliability, and influence on decisions. This cluster covers 134 papers. Representative work includes framing data choices, how predonation exploration designs influence data donation behavior and decision-making. BES, a decision-theoretic approach to evaluating large language model confidence, and prosocial persuasion at scale. Large language models outperform humans in donation appeals across levels of personalization. Trend 2 of 5, computer vision for specialized imaging. Applying computer vision and AI to analyze, enhance, and interpret specialized images from domains like medicine and remote sensing. This cluster covers 159 papers. Representative work includes COAM-EVL, scaling complementary multi-encoder vision language learning, VOSR, a vision-only generative model for image super-resolution, and Hyper-CT, low-rank HyperNet for unified chess-CT analysis. Trend 3 of 5, applied machine learning and systems. Applying machine learning methods to design, optimize, and integrate intelligent systems for practical, real-world problem-solving. This cluster covers 129 papers. Representative work includes, are statistical methods obsolete in the era of deep learning? A study of ODE inverse problems, enhancing robustness of federated learning via server learning, and fast best-in-class regret for contextual bandits. Trend 4 of 5, information theory and secure systems. This trend unifies information theory with system design to achieve security, robustness, and efficiency in data and communication. This cluster covers 65 papers. Representative work includes high-dimensional signal compression, lattice point bounds, and metric entropy, voting by mail, a Markov chain model for managing the security risks of election systems, and adaptive randomized pivoting and volume sampling. Trend 5 of 5. AI security and system vulnerabilities. This research explores AI system vulnerabilities, novel attacks, and the security implications of AI's increasing role in software development. This cluster covers 57 papers. Representative work includes kill chain canaries, stage-level tracking of prompt injection across attack surfaces, and model safety tiers. Help converts newcomers, not veterans. Generalized reciprocity and platform engagement on Stack Overflow. And from industry claims to empirical reality, an empirical study of code review agents in pull requests. Up next, our first paper out of 5, Verbalizing LLMs Assumptions to Explain and Control Sycophancy by Myra Chung and Dai Yang from Stanford University. Let's break down its key contributions. This framework elicits LLMs' underlying assumptions about user intent, such as seeking validation or information. It provides crucial insights into the root causes of sycophancy and other safety issues. Linear probes are trained on the internal representations of these verbalized assumptions. These probes enable interpretable and fine-grained steering of LLM behavior, specifically controlling social sycophancy. Up next, our second paper out of 5, Online Graph Coloring for $K Colorable Graphs by Kenichi Kawabayashi and Masadaka Yanida from National Institute of Informatics and the University of Tokyo. Let's break down its key contributions. This contribution introduces a novel deterministic online algorithm for coloring K colorable graphs when K greater than or equal to 5. It achieves a significantly improved upper bound of O(n)(1) 1/K 1/2 colors, surpassing previous results and matching the best K equals 4 bound. This contribution presents a specialized deterministic online algorithm for 4 colorable graphs. It establishes a new upper bound of O(n)(14/17) colors, which is a notable improvement over the previously best-known bound of O(n)(5/6). This contribution focuses on randomized algorithms for 2 colorable graphs, bipartite graphs. It provides both upper and lower bounds for the number of colors, specifically 1.03 for log 2 n plus O1 and 9196 log 2 n O1, respectively, significantly narrowing the gap. Up next, our third paper out of 5, Be Careful When Fine-Tuning on Open Source LLMs Your fine-tuning data could be secretly stolen. By Zhixin Zhang and Minlai Huang from Tsinghua University. Let's break down its key contributions. The paper reveals a novel data breaching risk where open-source LLM providers can inject a backdoor into their models. This allows them to later extract private fine-tuning data from downstream users. We propose a simple, stealthy backdoor training method that enables the provider to extract fine-tuning data. This attack only requires black box access to the downstream fine-tuned model, making it highly practical. Comprehensive experiments across 4 popular open-source LLMs and 2 downstream datasets demonstrate the attack's striking effectiveness. Up to 76.3% of fine-tuning data can be perfectly extracted, highlighting the severe risk. We investigate detection-based defense strategies to mitigate this risk, but find they can be bypassed with improved attack methods. This highlights the urgent need for robust countermeasures against such data breaches. Up next, our 4th paper out of 5, Amortized Inference of Causal Models via Conditional Fixed-Point Iterations by Divyat Mahajan and Meyer Setbon from Mila, Université de Montréal. Let's break down its key contributions. This framework enables a single model to predict causal mechanisms for various SCMs, conditioned on observational data and causal graphs. It allows generalization across datasets, addressing the limitation of training separate models for each. A transformer-based architecture is employed to learn amortized dataset embeddings. These embeddings concisely represent the observational data, facilitating the transfer of causal knowledge and enabling efficient processing across diverse datasets. The fixed-point approach, FIP, is extended to infer causal mechanisms conditionally on the learned dataset embeddings. This allows the model to predict mechanisms for novel SCMs at inference time without parameter updates. Up next, our 5th paper out of 5, the Systematic Security Evaluation of OpenClaw and its variants by Yuhang Wang and Shiguo Lian from Xidian University. Let's break down its key contributions. The paper constructs a benchmark of 205 test cases covering representative attack behaviors across the agent execution lifecycle. This enables unified evaluation of risk exposure at both framework and model levels. The methodology involves analyzing risk propagation across 4 key stages: input ingestion, planning and reasoning, tool execution, and result return. This systematic approach helps understand how early-stage weaknesses amplify into system failures. The paper conducts a systematic security evaluation of 6 OpenClaw series agent frameworks under multiple backbone models. This assesses agent system behavior under realistic adversarial conditions, considering tool invocation, planning, execution, and state persistence.